Hello, welcome back to BlenderSushi live noding. So still with the basic functions, we're gonna investigate one more. It's actually the triangle wave. The other day I kind of mentioned I said it's a sawtooth. Apparently it's not sawtooth. Sawtooth is more like almost like a loop. Actually, it's sawtooth is different. This is actually it's kind of similar to the curve loop, where you start from 0, go to 1, and back to 0, go to 1, and repeating. Anyway, we're gonna recreate this triangle wave today, and we're gonna be using animation nodes. And then if you want to trace it, you can use sphere chalk. It's a basic stuff, but I think I have to do it anyway. If you want the summary right away, if you have a frame here and you plug it into multiply, modulo, subtract, and absolute, you get this triangle wave. The funny thing is, I tried sine and arc sine. I also get a similar kind of result. I don't know why. So it's pretty much like a triangle wave. Now, how did I get to this point? I Google search and I got to this StackOverflow, and then I got this bunch of useful formula and curve. And there's one answer here by Noldorin. He mentioned about square wave and then triangular wave. This is the triangle wave that I was talking about. Sine wave, we already know you can multiply to get more amplitude and frequency and all that kind of funky stuff. But I just grabbed this guy, okay? Triangular wave. Let's turn on this tree and I'm gonna paste the formula here just for our reference. Y equal a absolute of blah blah blah. This, okay? Let's do it. It's supposed to be simple, but it's still a fun thing to investigate. Instead of a cube, I'll make this guy in a single point. So I'll go to edit mode and tap the spacebar and then merge it into a single point. Now I'm gonna animate this single point. This is gonna be triangular wave demo 001. This curve is apparently really useful, and it's one of the curve that's the most eye-pleasing. The second maybe the sine wave, or maybe sine wave the first one. This is the second more eye-pleasing and very useful. Y equal absolute. Now if you look at these functions, it's sometimes not so easy to know where to start with, but start with the one in the deepest bracket. X plus plus means it's a iteration, so we're gonna use frame for that. X plus plus is a frame number, because frame number is gonna go from 0 and going up, keep going up until the end. You can use modulo for that, so math modulo, and this guy. Let's debug this real quick. So what's gonna happen now? It's gonna go from 0 to 1 2 3 4 and keep repeating. Let's use transform object. Actually, object transform output. Get the point. Let's rename this point, and we're gonna make changes to the position. Let's see, we're gonna plug the functions into the z-axis. The y-axis can keep going. So first of all, I'm gonna create another math functions and plug the frame number into this guy, and this should be slower, like 0.1. Plug into the y-axis, not the x. X can remain 0. So now if we play back, so the point's moving linearly in the y-axis. We're gonna make the z moves in our triangular function. So currently we have modulo. Modulo is just like a loop. Okay. Oops, it's super fast at the moment. Maybe use the same multiplied time. So now you can see the time goes up and it jumps down. Once it's reached 5 units, it jumps down and then continue on. It's gonna create like a loop in itself. In order to be more clear, I will use particles and just let's say how many. We have 250 frames, so for each frames I want the particle to kind of emit and leave a motion trail. Turn off gravity. So now particles being created every frames, and then you can see once it hits unit 5, it's gonna jump into 0 again. So that's the effects of modulo. Now let's continue on. So we have the modulo and then -3. Okay, -3. Subtract. It's actually, I'll try -2 for now. And then we have absolute. So absolute is another function. Absoluto. There we go. The result can go into the y-axis, no, the z-axis, because the y is just a constant value. Alright, now let's have a look. It goes up and still doing the modulos thing. I think I did something wrong here. So modulo, maybe modulo 6 and then subtract by 3. I was using a negative just now, which is wrong. That's why it didn't work. Now it's working properly. Let's speed up the simulations. Actually speed up this function. Okay, now we have triangular wave. Currently, let's look at it from right view orthographic. See, currently it's going up 1, 2, 3 unit, and then goes down, up again, goes down. So we can kind of normalize this. So instead of 6 and 3, let's have like 3 and 1. Or in fact, just make this 2 and 1. Now it goes up and down really fast. We can slow it down. Okay, we have our triangular wave. Of course, this is really useful because it's just like unlike flip-flop that goes on and off in a snap. This one actually slowly going down and slowly going up again in a linear fashion. It's just like the sine wave, but we don't have accelerations. This is just like linearly going up and down. This is really useful in a motion graphic. I'll gonna prove it to you. So if we have like let's use the what should we have, the monkey or cone. I rarely use cone actually. Let's do that. Cone, give it a material, shadeless, object color on. Now we can make instance of this guy. Make this guy smaller first and increase it up. Okay, let's do the same like in previous live noding. We just gonna copy instance object instancer and grab our cone. How many instances? Don't know yet. Create a plane, grid, and grid will give points. So we're gonna loop through each vertices of points. Vertices plug into the instances. We know, okay, the total number of the instance, and then here object list. Plug this guy in. Now we can have object attribute output, color, and then object plug in there. Value has wrong type. Okay, that's no problem. Vector plug into the transform output. Okay, and there you go. And I believe we don't have anything yet, but soon, if we use mix color, it's gonna work for us. Mix color gonna mix maybe value between, let's use different color, orange and blue, orange and teal. Okay. Alright, that's okay. And the value, if I make it like this, that's the original. Okay. See, I can make the value goes into between those two values. Okay, we need to incorporate this guy into our loop. So just plug this guy into the vector. So now, yeah, it's doing its job. It's between 0 and 1, I believe the value is. Debug it. So 0, 1, back to 0, back to 1. Cool. That's exactly what we want. If we want to randomize it, just like the other day, we simply use a time delay, and time delay and the index should do the job. So it's ups and down. Very, very neat. Let's get rid of the relationship lines. What if I switch to material? It's a little bit brighter. Okay, a little bit like this. So from the functions that we learn, again, we get something that's pretty cool. Pretty simple but cool result. Can change value, so between purplish and teal. It's very beautiful color. Yeah, you can randomize it. We are not dealing with particle instancer, but you can actually use this what we have here for instancing. Actually, let me think. Maybe I'll do that in the next live noding video, but for this, you can, apart from the mix color, you can also use let's see, random color and a combined color. Let's try this. Maybe randomize the number. Hue saturation value. I think we can just plug this guy there, and then saturation value on, and then this guy going there. So now we have kind of like a value that goes between random value, but still we can see like some kind of order, right? That's why it's quite appealing, even though it's really, really simple. it goes across the spectrum of rainbow, and it creates this. See, if we have like 400, it's more. It's kind of like a small, slow wave going up and down. That's I kind of like this one. Just plug in there. So you can see like a. In fact, it's more like a color ramp, like a really linear gradients. If I'm not wrong, if you use like absolute with this triangle, you get a very sharp kind of curve. Because all these functions that we have learned, like sine wave, triangle, and a square wave, we can apparently use that to generate textures. I'm not gonna do that now, but if you're really into it, you can do a little bit more research. And if you check on a OSL, Open Shading Language, also use a lot of functions, and it's all just numbers, but it becomes kind of like a procedural textures because it goes through math functions. I could add like a noise here. For example, if I use like a wiggle, vector wiggle might do the job, although this might give an alpha channel that we don't have in here. I'm gonna try anyway. So combine color, and we have vector here. I'm gonna plug the vector into this separate vector. So vector wiggle will output some kind of random RGB or random XYZ. If I plug this guy there, and then time goes into the evolution, actually maybe time delay go to the evolutions, the output's gonna be vector, and the vector we can plug into RGB or HSV, and then the result of this color we can kind of mix with the other color. Yeah, it's a bit complicated, but this might be interesting. So you can see the original nice linear color change, and the one that's more random noise. I can switch to HSV. I think maybe it's gonna give a different kind of look. Ah, okay. Maybe just the hue. Ah, yeah, that's interesting. That's actually the number wiggle there. If we find the in between, so that's the number wiggle, and then we find the in between, we kind of get that color. Quite strange color combinations, but maybe that's what you want. If you look at it from the top, it's sometimes the ability to see the simple stuff in a complex setup is the key to understand complexity, I guess. XMY, this one 10. Actually 10 and 20 looks nicer. It's kind of the ratio of a panorama. Yeah, that's quite nice. If you want, you can animate this as well. See, we have all this color, but if we plug into the locations, we're gonna get something quite interesting. Vector map. So where's the ups and down? The ups and down is here. Let's plug this guy in there. See, our cone is kind of making this pattern. This is almost like the motion of some kind of worms. You can combine it with noise and so on, but anyway, I guess that's this is pretty much what I want to show you. I can control the noise here. Situation. That's kind of a very pleasing looking color. Let me delete the point. Okay, we don't need to see that. Let's look at it in a full screen. Matcap, oh, not matcap. Ambient occlusion doesn't work. Texture. Okay, Alt A, and we have our color. Yeah, so that's a triangular wave. It's rather basic, but perhaps more interesting. Actually, it will be useful for you if you wanna effort generate something that's kind of doing a motion that's like from one position to another position. Maybe in the future, live noding, I'm gonna just use the functions without needing to explain all this. Yeah. Okay. If you have any comment, questions, you can leave it down below. I'll see